So for these notes, our content language objective is students will be able to create, in writing, equivalent expressions using combining like terms with an equal sign and the following language: if-then statements, equivalent, inverse, eliminate, distribute, combine, and term. So in your own words, tell me what you think we're going to do today. All right, so if I start with the vocabulary, remember term from the last lesson was any set of numbers and letters together as long as there's no plus or minus, because the plus sign separates terms. For example, these are two different terms now because the plus sign separated them. And then combine meant to add together or to count. So those were from the last notes. Our goal is to create equivalent expressions. Remember, expression just means math. So equivalent is the first vocabulary word that's new. Equivalent just means equal to. Another way to think about that is the same. So if two things are equivalent, so they're the exact same or they're equal to each other. The next word we're going to need to know is something called an inverse. If two things are inverses, they will eliminate each other. So I'll explain what I mean in a second. But they eliminate each other if they're inverses. The word eliminate, though, means to cancel. You can also think of it as to get rid of. If you're eliminating something, it's going away. It's going bye-bye. It will not be there anymore. Inverses will do that. They'll get rid of things. And then the last word is distribute, and we're going to need to distribute. And distribute is a big word that means multiply in two parentheses. So the difference between the first set of notes and this set of notes is now there is an equal sign. So equal signs, sort of in math, you're going to always want to think of them as walls. They separate it in half. And what they're saying is this whole half, this whole thing is equal, the exact same. It is equivalent to this whole side right here. We don't know what the letters are or what they represent, but we do know that they equal. This half, it equals this half. So like if you were to weigh them on one of those scales, you know those scales where it's like this is one side and this is the other side? It's like it's one of those scales where it weighs things. So this is the middle, and it's like a bar, and it has this beam that rests on it. And that beam dropping down has two plates. Let's say this plate's holding something really heavy, so it sinks because there's something on it that's really heavy. Then because this side's sinking down, this side would rise up. And so it'd kind of be up here. And so this would show that this side's heavier because this side's sinking down more because it weighs more. Versus if this side was heavier, then it would look like that side is sinking down, and then this side is up here because it's lighter on the little beam. But if two things are equivalent and they're equal weight, it would cause the two plates to be at the exact same height because they weighed the same amount. And that would be called equivalent. They would be of equal weight. So right now, these two halves, they're equal in weight. So when we combine like terms and there's an equal sign involved, we have a goal. And our goal is to combine all terms over to the left side so that the equation equals 0. Here's our goal. All of these, we don't want them to be here anymore. We want them to all move over there so that at the end it's going to equal nothing, because we're going to make them all go away from the right side and all move over to the left side. So how are we going to do that? So here's the thing. If they were on the same side of the wall, on the equal sign. Like if it was all over here and I'm only looking at this half, if we had any like terms, we could just put them together. For example, right now I have this 5y squared minusing another y squared. Quickly, how many y squareds are in this term? It's a -1. Negative because of the minus, and then because there's no number, it's the invisible 1. And then if I did 5y squareds minus 1y squared, they can combine to what? What is 5 minus 1? Together, these two combine to 4y squared. And then on the right side, there's no other x terms. There's no other just number terms. There's no other x squared terms. And there's no other y squared. So nothing can combine on this right side of that equal sign. But if they're on separate sides of the equal sign, I cannot just put them together. Like I cannot take these two x's and just combine them with this x to get 3 x's. That is not true. Because it's not like they're on the same side. They're on different sides of this wall. And to move over the wall, I can't just hop on over. I have to first get rid of it from this side. So if I want to get rid of this x, to move across the equal sign, here's how we do it. Use the inverse to eliminate a term on one side. Then do the same thing to the other side to keep the equation equivalent. Another word for equivalent is balanced. If I go to that idea of the scale where you want them to stay equal or balanced. So when I say use the inverse, let's talk about what's going on with each term. Each term is either getting added or subtracted to the one before it. So remember, inverses get rid of things. So let's pretend I start with $5. And then I somehow find $4 on the floor. I want to undo the fact that I just got $4 more. And I don't want to have more money. I want to stay at $5. To undo adding 4, what do you think the opposite of adding is? Subtracting. So if I add 4, but then I give it away, I'm still at $5. So the inverse of adding is subtracting. And vice versa, the inverse of subtracting is adding. So adding and subtracting undo each other. Which means, right here, if I have an x, and it's one x, because there's only one of them, and I want to get rid of it, I don't want it on the right side anymore. How am I going to get rid of having an x? I'm going to minus it away. Because remember, this is like a positive x. So the opposite of adding is subtracting. So on this side, I've minused x. So they cancel. They eliminate. But what happened was I just made this side lighter. I took something away. So now this became unbalanced. This side is now heavier than this side is. So I have to keep it balanced. So if I took an x away from the right side, I also have to take an x away from this left side. And I have to make sure I combine my like terms. So it can't go away from an x squared. I can't take it away from the 4, it's just a number. I have to take it away from these two x's. So I have to minus the x from right here. Now this line is going to say equals. So I see the math, and my math's going to go straight down. So there's nothing under this 6x squared, so I get to just bring it down. Just have that 6x squared. This plus 4 has nothing underneath it, so it also just gets to come straight down. And this is where the math is. If I have 2 x's and I'm minusing an x, how many x's do I have left? I have 1 x left. So it's plus because I have it. I don't have to write the 1. I could, but x just means there's one of them. Then finally, this 4y squared also has to come down. So I still have plus 4y squared. Then it's still going to equal, on this side, the 1x minus x canceled. There's no more x's. I don't have to write it. This 3 is positive, so I can just start it off with the 3. I don't have to write plus. I still have the x squared, though. And I still have the minus y squared. All get brought down. All right, so since I subtracted x from both sides, they go back to being imbalanced. So we're good. Next, to get rid of this 3, remember it's a positive 3. I had a plus, and the inverse of adding is subtracting. So I need to minus those 3 away. Which one over here am I going to minus 3 from? I'm going to minus it from the 4 because it's the just number term. Then I'm going to bring down all my math. Don't forget that this positive 3 minus 3 will eliminate and cancel. So the 6x squared has nothing beneath it. So I just bring it down. Here, this plus 4 has a minus 3 beneath it, and 4 minus 3 is positive 1. The plus x just comes down because there's nothing beneath it. Plus 4y just comes down, or 4y squared, I meant. And then we still have equals. The 3 minus 3 canceled. I still have a positive x squared and a negative y squared. And because I did the minus 3 to both sides, it stayed balanced. All right. Next, how am I going to get rid of this x squared? How am I going to eliminate it? I minus it away from both sides to keep it balanced. So which one do I subtract it from over here? I subtract it from the 6x squareds because it's an x squared term. So when I do 6x squareds minus this 1x squared, because there's no number in front, so it's like a 1. With 6 minus 1, we have 5x squareds left. This plus 1 just comes down, plus x, plus 4y squared. And it's going to equal, on this side, the x squared minus x squared canceled. But I'm still left with a minus y squared. All right, and then to finish it up, to get rid of this negative y squared, what do you think we have to do? We have to add it away because the inverse of subtracting is adding. So that will eliminate it on this side. But then I also have to add it to this side. And which one am I going to add it to? The 4y squareds. So I need to add this y squared over here as well to this one. And then when I do my math, I get that I still have 5x squareds plus 1 plus x. Then 4 squared y squareds adding another one becomes how many y squareds? 5 y squareds. They're positive, so I had to put the plus. Now it equals, when this one cancels and there's nothing left, it equals 0. So now I am done, because remember from the very beginning, my whole goal was to combine all my terms over, take them all over to the left side, so that it equaled 0, which it does. And note that this equation up here is equivalent. It is the exact same thing as this one down here. We didn't change it at all. We just wrote it differently. We wrote it in a way so that all the like terms were combined and they were all moved over to the left side. So that's the basic concept. I'm going to do it again here with parentheses, because if there's parentheses, we have to distribute. And I'm going to break it into steps. So step 1 is always going to be distribute into parentheses. So if I take this, if there is a parentheses around a lot of things, and you cannot combine those things because you can't combine x squareds with xy's and with y squareds, Then the next thing you should say is there's something right in front of the parentheses. Yes, this time there's a 2, a positive 2. And that number, whatever the one right in front of the parentheses is, needs to get multiplied into everything, every single term in that parentheses. That's what it means when there's a number right in front. So I have to do it for that one. And then if I look later on, there's another parentheses. And I cannot combine the x squared with the y squared. So the rule is first you have to say what's right in front of the parentheses. It's not just 3, it's a minus 3. And that matters because that negative 3 needs to get multiplied into both terms in the parentheses. So when I do the math, for this first one, 2 times negative is just negative 2. Remember, you could think of it as like a negative 1, and 1 times 2 is just 2, and then the negative. And then there's still x squareds. Then for the next one, 2 times that 2 becomes positive 4, and they're xy's. Then, because there's no number here, it's just a 1, and then that 2 times that 1 becomes a positive 2, and then there's still y squareds. Then I can't forget that I still have this minus xy that has to come down too. Then the equal sign, then the 3xy, but then now the next part's a part of my multiplying. So remember there's an invisible 1 in front of this x squared, and 1 times negative 3 is negative 3, and then they're x squareds. And this one right in front of the y squared, there's an invisible what? It's an invisible 1 that's negative because of the minus. So negative 3 times that negative 1 becomes what? Positive 3. And then they're y squareds, and I can't forget that. Now I've done step 1, distribute into parentheses. Step 2 is to combine like terms that are on the same side of the equal sign. So if we have any like terms on the same side of the equal sign, we should combine them. So on the right, and only on the right, do I have any more x squareds? No, no, no. I don't care about this side right now. On the right, do I have any more xy's besides these 4's? No. Oh, look, here's a minus xy. So I can combine these 4xy's, they're positive 4xy's, with this negative xy. So when I do what's 4 minus the xy, the 1xy, it's 3xy's. Then I have to keep going for this step. Are there any more y squareds on this side? No. Now we look at the right side. Are there any other xy's on this right? No. Are there any other x squareds on the right? No. Are there any other y squareds? No. So we've combined all the terms that are on the same side. Step 3, to use inverses to move over the equal sign to make the whole thing equal 0. So now I'm going to take this and I'm going to do that step. This time I'm going to do it a lot faster though, because I could do it all at once. You don't have to. You can go one by one if you want. But watch. If I have 3xy's on the right, I can get rid of them by what's the inverse of adding these 3xy's. I minus them away. And what term should I minus them from on the left? The 3xy's. So I'm going to minus 3xy's right here. Then I have a minus 3x squared on the right. And to get rid of it, I would have to add the 3x squareds. And which term am I going to add it to on the left side? The negative 2x squareds. So for this one, I'm going to add the 3x squareds over. Then if I have plus 3y squareds and I want to cancel it or eliminate, how am I going to get rid of adding 3? I'm going to subtract the 3y squareds away. And which term am I going to subtract it from over here on the left? the 2y squareds because I got to keep my y squareds together. So then I'm going to minus the 3y squareds from the other side over. And now when I do all the math, on the right, everything's going to eliminate. This 3 minus 3 cancels. This minus 3 plus 3 cancels. This plus 3 minus 3 cancels. Every single term is going to go away like I want it to. And then I'm going to end up with an answer of, if I do negative 2 plus 3, I get what? I would end up with a positive 1x squared. Remember, I don't have to write that one. Next, if I do plus 3 minus 3, what do I get? 0. These eliminate, these cancel as well. I don't have to write 0xy. I could do plus 0xy, but I don't have to because it's nothing. So why write it? Then over here, if I have 2y squareds, but then I'm minusing 3, how many do I have left? I don't have any. I'm actually down 1. Because 2 minus 3 is negative 1, y squared. And again, I don't have to write the 1. I could just say minus y squared if I wanted to, because it means minus 1. And then it's going to equal, on this side, there's nothing left, so it equals 0, just like I want, so this would be my final answer.